Need for rational numbers. In the chapter of integers, we have learned to represent loss, decrease, fall, etc. by using integers. Now, how will you represent 750 meter below sea level in term of kilometer? You know that 750 meter is equal to 750 by 1000 kilometer, which is equal to 3 by 4 kilometer, and below the sea level means minus 3 by 4 kilometer. Is minus 3 by 4 a fraction or an integer? Of course, none of these. Let us now introduce a new class of numbers called rational numbers. What are rational numbers? The word rational arises from the term ratio. So, a ratio minus 4:5 can be written as minus 4 by 5. Here, minus 4 and 5 are integers. Thus, we can define rational numbers as follows. A rational number is defined as a number expressed in the form of p by q, where p and q are integers and q is not equal to 0. Examples of rational number are minus 5 by 7, 4 by 7, 1 and 1 by 2, minus 3 by 2, etc. Are all fractions rational numbers? Yes, because all fractions have p, q as the integers and q is not equal to 0. What about integers? Yes, all integers are also rational numbers, as 3 can be written as 3 by 1. The diagram given below will make you to understand the relationship of numbers. All natural numbers are whole numbers. All whole numbers are integers. Integers and fractions along with negative of fractions constitute bigger class of number called as rational number. Equivalent rational numbers. To obtain a rational number equivalent to the given rational number, we multiply the numerator and denominator of the rational number by the same non-zero integer. Example, write 4 equivalent rational numbers for minus 4 by 5. Minus 4 by 5 is equal to minus 4 into in the brackets minus 1 by 5 into in the brackets minus 1, which is equal to 4 by minus 5. Minus 4 by 5 is equal to minus 4 into 2 by 5 into 2, which is equal to minus 8 by 10. Minus 4 by 5 is equal to minus 4 into in the brackets minus 2 by 5 into in the brackets minus 2, which is equal to 8 by minus 10. Minus 4 by 5 is equal to minus 4 into 10 by 5 into 10, which is equal to minus 40 by 50. Positive and negative rational numbers. Negative rational numbers. If both the numerator and denominator of a rational number have opposite sign, then the given rational number is a negative rational number. Example, minus 4 by 5 and 7 by minus 3 are negative rational numbers. Positive rational numbers. If both the numerator and denominator of a rational number have same sign, that is either both are positive or both are negative, then the given number is a positive rational number. Example, 4 by 5 and minus 7 by minus 3. Both are positive rational numbers. Some important results. A. 0 is a rational number, as 0 can be written as 0 by 1 or 0 by minus 2 or 0 by 100, etc. B. Every natural number is a rational number, but every rational number may not be a natural number. Example, 5 by 3 is a rational number, but not a natural number. 7 by 1 is a rational number, which is a natural number also. C. Every integer is a rational number, but every rational number may or may not be an integer. Example, minus 4 is an integer as well as a rational number, but a rational number 14 by 2 is an integer as well as rational numbers. 4 by 5 is a rational number but not an integer. D. Every fraction is a rational number, but every rational number may or may not be a fraction. Example, 4 by 5 is a fraction and a rational number too. Minus 4 by 5 is a rational number but not a fraction. Rational numbers on number line. Positive rational numbers are represented to the right of 0 and negative rational numbers to the left of 0. To express a given rational number on number line, we divide the unit length into the number of equal parts as the denominator of rational number and then mark the required rational numbers on the line. Let us represent the following rational numbers on the number line. A. Minus 1 by 2. B. 3 by 4. We first divide the unit length on the left side into two equal parts. Thus, part OA represents minus 1 by 2 on number line. B. We divide the unit length on the right of 0 into four equal parts. Thus, the part OB represents 3 by 4 on the number line. Standard or lowest form of a rational number. A rational number is said to be in its standard form if its denominator is positive and numerator and denominator have no common factor other than 1. To reduce a given rational number in its standard form, we can use any of the two following methods. 1. Successive division of numerator and denominator by their common factors. 2. Dividing numerator and denominator by their HCF, ignoring the negative sign if there is any. Example 1. Reduce minus 12 by minus 16 to its standard form. Solution. Method 1. Minus 12 by minus 16 is equal to 12 by 16 by changing denominator to positive sign, which is equal to 12 divided by 2 by 16 divided by 2, which is equal to 6 divided by 2 by 8 divided by 2, which is equal to 3 by 4. Thus, 3 by 4 is a standard form of minus 12 by minus 16. Example 2. Express the following rational numbers in its standard form. A. Minus 4 by 26. B. Minus 15 by minus 60. Solution. A. Minus 4 by 26. Denominator is positive. First, we have to find HCF of 4 and 26, which is equal to 2. Now, minus 4 divided by 2 by 26 divided by 2 is equal to minus 2 by 13. B. Minus 15 by minus 60. Denominator is negative, so multiply numerator and denominator by minus 1. Minus 15 into minus 1 by minus 60 into minus 1 is equal to 15 by 60. Because HCF of 15 and 60 is 15. Divide both numerators and denominator by 15. Therefore, 15 by 60 is equal to 15 divided by 15 by 60 divided by 15, which is equal to 1 by 4. Equality of rational numbers. Equality of two rational numbers can be checked by three different methods. 1. By changing them into equivalent fractions with denominator equal to their LCM. 2. By reducing them to their standard form. 3. By finding the product of the numerator of first with denominator of second and numerator of second with denominator of first, that is, by cross multiplication method. Example 1. Are minus 8 by minus 14 and 13 by 20 equal? Solution. We can check the equality of these two rational numbers by any method. Let us check in this example using lowest form method. Minus 8 by minus 14 is equal to minus 8 into minus 1 by minus 14 into minus 1, reducing denominator as positive number, which is equal to 8 divided by 2 by 14 divided by 2. HCF of 8 and 14 is 2, equal to 4 by 7. 13 by 20 is equal to 13 by 20. It is in its lowest form because 4 by 7 is not equal to 13 by 20. Therefore, minus 8 by minus 14 is not equal to 13 by 20. Example 2. Are minus 4 by 24 and 12 by minus 72 equal? Solution. Let us now check the equality of two rational numbers by the method of reducing them to equivalent denominator, that is, having denominator equal to LCM of 24 and 72, minus 4 by 24 and 12 by minus 72. or minus 4 by 24 and minus 12 by 72, changing denominator to positive. LCM of 24 and 72 is 72. Minus 4 by 24 is equal to minus 4 into 3 by 24 into 3, which is equal to minus 12 by 72. Minus 12 by 72 is equal to minus 12 into 1 by 72 into 1, which is equal to minus 12 by 72. Therefore, minus 12 by 72 is equal to minus 12 by 72. Hence, minus 4 by 24 is equal to minus 12 by 72. This implies that minus 4 by 24 is equal to 12 by minus 72. Comparison of rational numbers. We can compare two rational numbers by three different methods. 1. By representing them on number line. Convert numbers to equivalent fractions with denominators equal to their LCM. Then represent them on the number line. The numbers lying to the right of another number will be greater. Let us compare minus 1 by 2 and minus 1 by 5. LCM of 2 and 5 is 10. Thus, minus 1 by 2 is equal to minus 1 into 5 by 2 into 5, which is equal to minus 5 by 10. Minus 1 by 5 is equal to minus 1 into 2 by 5 into 2, which is equal to minus 2 by 10. Note that minus 2 by 10 lies to the right of minus 5 by 10, or minus 1 by 5 lies to the right of minus 1 by 2. Thus, minus 1 by 5 is greater than minus 1 by 2. 2. First, convert the given numbers into rational numbers with denominator equal to LCM of their denominator and then compare their numerator. Let us compare minus 1 by 2 and 1 by minus 5. Minus 1 by 2 and in the brackets minus 1 by 5. On changing to positive denominator, LCM of 2 and 5 is 10. Minus 1 by 2 is equal to minus 1 into 5 by 2 into 5, which is equal to minus 5 by 10. Minus 1 by 5 is equal to minus 1 into 2 by 5 into 2, which is equal to minus 2 by 10. Now, let us compare their numerator, minus 5 and minus 2. We know that minus 5 is lesser than minus 2. So, minus 5 by 10 is lesser than minus 2 by 10. Or, minus 1 by 2 is lesser than minus 1 by 5. 3. By cross-multiplying the numerator of first with denominator of second and numerator of second with denominator of first. To compare A by B and C by D, we multiply A into D and C into B. Then if A into D is greater than C into B, then A by B is greater than C by D. B. A into D is lesser than B into C, then A by B is lesser than C by D. C. A into D is equal to B into C, then A by B is equal to C by D. Some important points to remember while comparing two rational numbers. A. Every positive rational number is greater than 0. B. Every negative rational number is less than 0. C. Every negative rational number is less than every positive rational number. D. We can compare two negative rational numbers by ignoring their signs and then reversing their order. E. Every positive rational number is always greater than a negative rational number. Example 1. Compare minus 5 by 7 and 2 by 3. Solution. Minus 5 by 7 is a negative rational number and 2 by 3 is a positive rational number. So, minus 5 by 7 is less than 2 by 3 as a negative rational number is always less than positive rational number. Example 2. Compare minus 5 by 7 and plus 3 by minus 4. Solution. We first change 3 by minus 4 with a positive denominator. So, 3 by minus 4 is equal to 3 into minus 1 by minus 4 into minus 1, which is equal to minus 3 by 4. LCM of 7 and 4 is 28. Convert minus 5 by 7 and minus 3 by 4 into equivalent fractions having denominator equal to 28. Therefore, minus 5 by 7 is equal to minus 5 into 4 by 7 into 4, which is equal to minus 20 by 28. And minus 3 by 4 is equal to minus 3 into 7 by 4 into 7, which is equal to minus 21 by 28. Since minus 20 is greater than minus 21, minus 20 by 28 is greater than minus 21 by 28. This implies that minus 5 by 7 is greater than minus 3 by 4. Rational numbers between two rational numbers. We can find infinite rational numbers between two given rational numbers. Let us see how. Let us consider 2 by 5 and 3 by 4. Now reduce both of them to equivalent rational number having denominator equal to the LCM of 4 and 5, that is 20. 2 by 5 is equal to 2 into 4 by 5 into 4, which is equal to 8 by 20. And 3 by 4 is equal to 3 into 5 by 4 into 5, which is equal to 15 by 20. Since 8 is less than 15, this implies 8 by 20 is less than 15 by 20. Now, we can say that 9 by 20, 10 by 20, 11 by 20, 12 by 20, 13 by 20, 14 by 20, all these rational numbers lie between 8 by 20 and 15 by 20. Now we can write 8 by 20 is equal to 80 by 200 and 15 by 20 is equal to 150 by 200. Therefore, 80 by 200 is less than 81 by 200, which is lesser than 82 by 200, which is lesser than, and so on, till which is lesser than 140 by 200, and so on till which is lesser than 149 by 200, which is lesser than 150 by 200. This way, we can find approximately 69 rational numbers. And similarly, 8 by 20 is equal to 800 by 2000 and 15 by 20 is equal to 1500 by 2000. And hence, we can find many more rational numbers. Example 1. List 4 rational numbers lying between minus 4 and minus 2. Solution. Now, minus 2 is equal to minus 2 by 1. And minus 4 is equal to minus 4 by 1. Thus, minus 2 by 1 is equal to minus 20 by 10, multiplying denominator and numerator with 10. Minus 4 by 1 is equal to minus 40 by 10. Minus 40 by 10 is lesser than minus 20 by 10. Thus, minus 40 by 10 is less than minus 39 by 10, which is lesser than minus 35 by 10, which is lesser than minus 27 by 10, which is lesser than minus 22 by 10, and which is lesser than minus 20 by 10, are the rational numbers lying between minus 4 and minus 2. These are not the only 4 rational numbers lying between minus 4 and minus 2. We can find infinite rational numbers between any 2 rational numbers. So your answer may or may not match with your partner or with your teacher.